Welcome everybody to today's FDTD GOES 16 Applications webinar. Today we're pleased to have Chris Matarochia from the WFO in Hanford, California leading our presentation. The title of his presentation is Expanding DSS in Central California by Using GOES 16-17 for Fire and Fog Identification. So before we begin, just a couple things to note. First of all these are recorded and made available at the URL shown below, which is available off the visit web pages. Also, if you're interested in leading one of these presentations, let either myself, Dan Bicus, or Scott Lindstrom know, and we'll schedule you for a future webinar. Some protocol: we'll have about 20 minutes for our speaker. If you have questions, you can either send it via the GoToChat, or we will have a Q&A period over the phone as soon as he's done talking. That will be done by 18:30Z, and remember, do not press hold, and also mute your phone when you're not speaking. So at this point, I'll turn it over to Chris.
Okay, thank you. Good morning or good afternoon, everyone, depending upon what part of the country you're in. I'm Sue here in Hanford. I felt it was very important to really get our hands dirty using GOES 16 products last fall. So we'd be ready for GOES 17 or GOES West this year. In order for my office to fully understand the capabilities and power in the data, we spent a good amount of time in training regarding our two big events we experience in the West, which would be fire and dense fog. And the ultimate goal was to get buy-in for this new technology with several impactful examples that I'll go over today, and then integrating these examples with decision support services with our core partners. Next slide. So one of the most exciting aspects of the new satellite is nighttime fire detection. Although our fire managers never really put their ringer on mute, they're always aware 24/7. Identifying fires at night and alerting our partners can have a huge impact on getting to hotspots quickly. We found that last year, in some cases, we were able to provide a good amount of lead time. In other words, identify fires before anyone else on the ground knew they had started. This particular fire here, the Grand Fire, was just outside our county warning area, but it was a good example because the signatures popped up really quickly. The signature showed up at 9:17 p.m., but the California Department of Transportation didn't tweet out about the road closures until 2 a.m. So this is the 4-panel that we basically have our forecasters use. In the upper left, it's cut off, but that's the fire temperature RGB. Next slide. So this is a loop of the Pier Fire, and the Pier Fire was one of the largest fires in our county warning area last year. In fact, we just had a debris flow mudslide over the burn scar from this fire a couple of weeks ago due to heavy rain. And as you can see here in the image, one of our core partners, Sequoia National Forest, was quite impressed that we were able to identify and confirm the fire's existence. So on the left there is the Channel 7 imagery, and when you see that yellow spot is basically when the fire started. And then we were also able to identify it using the nighttime microphysics RGB product. There at the top right of the slide is pulled right from our shift log, and the forecaster basically remarked that we saw a hotspot on GOES 16 data just east of Springville, and the person we notified at the forest was pretty impressed and thankful that we noticed the fire and we confirmed it to them. So this is an example of directly using the new technology and then using it to help our core partners in the Sequoia National Forest. Next slide, please. So our largest fire last year was the Detweiler fire, and the satellite signatures matched exactly with the time of the fire start, which again I thought was really impressive. After an IMET was actually dispatched to the fire, we were able to communicate through NWS chat when we saw changes in fire behavior. So we had requested a mesosector over our area the day of the NWS chat. So we were receiving 1-minute data. We felt it was very important. So basically the fire started 3:57 p.m. on Sunday, July 16th. That was the first indication per the Channel 7 image. And again, this is another 4-panel that we have our forecasters use. So, we have fire temperature, we have the RGB, but we also have GOES 16 Channel 1 that we used, which really showed where the smoke plume was going. And the direction and this image of the smoke plume, we were able to pass that information along to our San Joaquin Valley Air Pollution Control District, so that provided some assistance for them. At this point, I'll focus on the snippet from the NWS chat. So if you look at 5:01 p.m. on July 24th, one of our forecasters, Jeffrey Barlow, was communicating with the IMET at the Detweiler. His name was Tom Wright. And the forecaster here at the office noticed that there was a change in fire behavior, that it flared up over the past hour or so. And actually the IMET on the ground confirmed that that did indeed happen, and that they were increasing air support over that part of the fire. So again, this is another example of us interacting with the IMET on the ground, that IMET confirming what we were seeing on the satellite data was actually happening on the ground. So again, this is another example where we can provide support through NWS chat to either the IMETs. Of course, they're looking at the imagery too, but they have a lot of people they're interacting with. We can sometimes focus on this a little bit more closely than they can. But this was just another example of how we can integrate this into our operation and improve our services. Next slide, please. Basically, this is just a zoomed-in loop of the 4-panel that our forecasters were monitoring, which showed the first start of the Detweiler fire. So I know the loop is a little bit slower than what I see here, so I'll just let this go through for a little bit here. But you can see the expansion of the smoke plume there on the upper right, and you can see the fire temperature RGB, which sticks out like a sore thumb there in the upper left, and the fire temperature in the bottom left, and then just the Channel 7 image in the bottom right. Next slide. So after there were a few RPM updates installed and some of the color curves were improved, we were promised, and we actually were able to verify that we were able to identify much smaller grass fires down to a few hundred acres a lot better than we were when GOES 16 data was first made available to us. And this particular fire was called the Famoso Fire. And if you'll notice there, again, Kern County Fire tweeted out information about this fire along Highway 65 at about 1:16 p.m. but the hotspot image that you see on the left there was from 12:47 p.m. So I was never able to figure out for sure if we saw this fire before anybody reported it or Kern County Fire became aware of it, but I think it's safe to assume that we were either able to provide lead time with this particular example or identify the fire per satellite about the same time that the public was seeing it on the ground. Next slide, please. So this is another image of the Formosa fire. This is the 4-panel procedure that the forecasters use for situational awareness. This was from an hour later after we first determined that the fire was starting. So what we have on here too, although I don't have it shown on the image, is we have identified where our solar farms are located, and those will provide false positives. So, our forecasters have become so acquainted with the data that they know where those false positives are, and they know where, what to look for actually in the data to notice something different and notice that this is actual a hotspot or a fire start, even with these smaller grass fires. Next image, please. So this was a fire that was detected probably with regards to our biggest core partner in our county warning area, which I'm sure everyone knows of Yosemite National Park. They have many personnel that are dedicated to fires in the park, so they're usually really situationally aware. But this is just another example of a signature that occurred right around the fire start. This happened pretty close to Wawona. There's a lot of major roadways that go through this area that people enter the park on. And this was the South Fork fire. So this came directly from Yosemite, that the fire was first discovered at 2:30 p.m. Basically, the first image we saw that indicated a hot spot was at 2:37 p.m. So, 7 minutes, that's really pretty close to when the fire was actually observed to have started. Next image. So again, here is another example, and this was another example of early detection. This is the Cottonwood fire, and this started pretty close to a heavily traveled roadway in our CWA, State Route 58. By the satellite, we were first able to detect the hotspot or this fire at 12:17 p.m., and that was on October 9th. By the evening of October 9th, the Cottonwood fire ended up destroying 3 homes. It burned 45 cars and killed 5 horses. There were 2 homes affected that had no residents. They were just basically homes that nobody owned. One of the homes did have residents, but they were not there at the time of the fire, thankfully. One thing that did happen, though, with this fire is that there was an elementary school that was pretty close to the explosive growth of the fire, and that elementary school was basically evacuated due to this fire. So, again, this is just another great way that we can inform our partners to give them more lead time with these images so they can get that school or get areas evacuated before these fires become too large, because, especially in our area with regards to drought and things like that, these fires explode and grow pretty quickly, so that lead time is of utmost importance. Next slide, please. So because our staff has become so acquainted with the signatures in the GOES imagery, I installed something called the Hotspot Notification Tool. Now, this code was written by Aaron Anderson. He's the IT at the Norman Forecast Office. And they did a lot of testing with this tool even before GOES 16. They used it with the legacy satellite, despite the reduced temporal and spatial resolution of the legacy satellite. So this is still experimental, but we thought this would be a good idea to try out in our area. And basically, what I had to do was do a lot of outreach with our fire managers and our fire partners to figure out exactly which phone was in their operational area that was accessible and turned on 24/7, so that when we sent the text message to that particular phone, that it was active, that it would make a noise or light up, or somebody would notice it right away in the operational area, especially during the nighttime, for these nighttime fire starts. So this particular fire was the Indian fire. It was one of the smaller fires that we had in our area, but the text that you see to the right of the image is what the text message looks like. So basically indicates the county, it indicates a fire weather level, and we get that directly from our regional fire partners that they determine earlier in the day whether it's a low risk, a medium risk, an extreme risk, a high risk type of day. So although the fire folks are aware of that, that kind of gives them a little bit of information as far as what the potential is for how quickly this fire can potentially spread. The tool also provides the closest mesonet information as far as wind direction and wind speed. It gives them a lat lon, and it also provides us at the forecast office for providing them comments about the fire as far as some landmarks that the fire weather folks would be more familiar of, as opposed to just giving them a latitude and a longitude. So we're still testing this out in Western Region, and it's experimental, but this is a great tool, and Aaron Anderson deserves a lot of accolades for this, and everybody on the call. I urge you to try this out, especially if you're in the West, and you'll have access to GOES 17, hopefully this fall. Next slide, please. So the next thing that I'll touch upon briefly is another major thing that we deal with here in the Hanford County warning area, which is fog and fog identification. Dense fog, we call it Thule fog here, and the Central California Valley is the #1 related cause of weather fatalities in our area. So this is like our severe weather. These fog events are very tough to predict with lead time. The models don't really do that great of a job with giving us lead time. There's a lot of false alarm, but we have noticed an improvement with the national blend of models with regards to visibility and fog prediction. However, last season, the GOES 16 really helped us to identify fog quicker than a lot of the legacy methods that we typically use to identify fog during the nighttime periods. So the image in the upper left is from about a 50-car chain reaction crash that happened at the end of January 2017. And the images on the right that's another chain reaction crash. That's a different event. The image on the right is a visible satellite, which shows how extensive across the Central California Valley this fog can spread, and it even goes up into Sacramento's county warning area at times too. Next slide. So here is one of the examples of fog detection from last season. Now, normally our office, and still does, and it's still a great product, uses the IFR and the LIFR GOES probability to detect fog. But we found that using the advanced microphysics image gave us a little bit better lead time and situational awareness with regards to fog. Then, like I said, our previous relied upon LIFR and IFR probability images. In the loop that you see on the right, the dark blue is indicative of clearing and dense fog formation and movement. And this was verified by the ASOS sites that you see near that dark blue. It might be a little bit difficult to see that they eventually show quarter-mile visibility. Of course, however, the ASOS sites were slower to respond to the fog than the satellite. There is also a dark blue portion of the image that shows up over Edwards Air Force Base. That's in the extreme bottom right-hand corner of the image. And that's basically desert area, and they don't really get fog a lot, so when they do, they're a little less sensitive to fog development down there. So not only did the advanced microphysics image help us with identifying fog in areas where it normally occurs, but it also helped us identify fog in areas where it doesn't really occur too often. Next slide, please. So again, this is just a blown-up image of the loop, and I do apologize. It does play a little bit slow here with the connection, but you can see some of the ASOS sites a little bit quickly that verify that we actually had reduced visibilities with this particular fog event. Next slide. So one thing I'll say about that last slide is that was actually after the satellite had moved to the east. So we were still able to use the satellite, despite us being in California. We still had useful data to identify fog, even though the satellite had already moved, and that was something that I thought was also pretty impressive. So because of our increased lead time with the satellite, and also because of the skill that we found with the national blend of models, our office was able to produce an image to show the Department of Transportation in California where the most dense fog was located. There's a sensitivity to fog in this area, and people are really used to it. So when we issue dense fog advisories, they always don't gain the traction that they would in maybe another county warning area. A quarter-mile visibility around here really isn't that big of a deal, and Caltrans really doesn't increase their operations when they have quarter-mile visibility. And we were a little bit concerned with that, so we've merged our SOPs. We've done dense fog simulations and IWTs, not only with Caltrans, but also with the California Highway Patrol, to introduce them to this imagery. A lot of our chain reaction crashes occur when we have something called the wall of fog. So basically, these are very small areas of very dense fog, and we're talking about fog down to zero. So with this particular image, these smaller numbers that you see overlaid here are images of overhead messaging signs. So when we send this image to Caltrans, California Highway Patrol, it's not perfect, but they're better able to see spatially where the densest fog is located at. So what they'll do then is they will activate some of these signs that are outside of the orange and the yellow areas to inform motorists who are probably traveling the speed limit that they really need to reduce speed because they're about to hit an area where the fog is down to 0 or 250 feet. And basically, we feel that that can really help reduce the amount of chain reaction crashes that occur. So again, with the extra lead time that we're provided with, the satellite products, we're able to provide this information to one of our core partners. The last thing that I'll basically say is that it's really vital that we have smart inits for GOES 16 and 17 data, and also for the GOES IFR and LFI probabilities to improve this image in this project. This image is basically created from the SACGrid image maker. It runs automatically. There's only forecaster intervention if the models are not doing a good job with identifying the fog. So there's really not a lot of workload issue with this. So if we're able to get these smart inits by build 18.2, we can initialize this data much better, and it'll be a little bit more accurate than it is now. Next slide. So this is just another example of fog detection. We'll speed up here because I'm running a little bit late. But you can see here that the bottom left and bottom right images, the bottom left was the fog channel difference product, the bottom right was the nighttime advanced microphysics. Both of those showed fog in our area about an hour and 15 minutes before the LIFR, IFR probabilities did in the upper right-hand portion, and then the old legacy fog, I call it the counts product, in the upper left-hand image. So at 9:15Z, we were seeing images in the bottom left and the bottom right already indicating fog development, where the images in the upper left and the upper right really weren't showing any indications of fog at all. Next image. Next slide, I guess. So this is just blown up a little bit, and again, you can go back and look at the recorded presentation and examine this a little bit more closely. Next slide. So that's basically all that I have. I thank you for joining me today and giving me an opportunity to show how we're integrating the great new technology with GOES 16 and 17 into decision support services. And I'll open the floor for any questions.
Hi, Chris. This is Scott at Sims. I just wanted to point out that the IFR probability that you showed before GOES 16 became operational, it was still using GOES 15 data.
Right.
So that was, after it became operational, I think the comparison to the brightness temperature difference from GOES 16 and the air mass RGB, or the nighttime microphysics, will be a better comparison.
Yeah, I totally understand that. I talked with you folks last fall, basically, and I think somebody told me that it was going to take a year to for the regression equations to catch up to the new GOES data. I guess maybe that's sped up now as far as the IFR and LFR probability is concerned, but I guess that's what you're telling me right now. So
right. I think they're tweaking the equations now, but they have a good first approximation to the Bayesian equations that they're using. And GOES 17 data will not be incorporated into this again until it's operational.
Okay.
So you'll be relying on GOES 16, which, as you know, gets you pretty much almost all the way there.
Right. No, that's great to know. Thanks for that information. Yeah, fog is a real challenge for us here, and we're always trying to give our partners better lead time. You know, we like to try to issue dense fog advisories, and we have something here that we're trying out called the Fog Severity Index. We like to get that stuff out, maybe 24 hours in advance, because a lot of these smaller towns don't have the resources as far as police departments to get pace cars out to slow down the traffic to prevent some of these chain reaction crashes. So all of this will help us give them more lead time.
Any more questions for Chris?
Hey, Dan, this is Ed. I had a quick question. Chris, you showed the one example where you said Edwards had the desert area had some fog, but there were two stations and they didn't seem to report any. Did you have some other verification down that way?
Yes, we did. We had somebody on Facebook actually that day reported that there was dense fog in that area. So even though Edwards wasn't really indicating anything there, we had it on the satellite image, and we did have a Facebook report that there was fog down there. So it's pretty hard to get fog in the desert. So it was great that we had somebody verifying that information from the satellite for us.
Okay, thanks. Yeah, very, very good presentation.
Thank you. Appreciate it.
Okay, any other questions for Chris?
Yeah, hey Chris, it's Brian Mata. You mentioned the fires and you mentioned the fog. Any commentary about the smoke in either case, combining with the fog or in the fire situation?
Yes, we've also looked at the smoke too. I have a couple examples of smoke being identified by the Channel 1. That again, we've provided that information and a little bit of training on that to the San Joaquin Valley Air Pollution Control District. As some of you may know, air quality is terrible in the valley in the summertime. So when we get these fires and we get the smoke moving, it's very important for those folks to know. I mean, they have their own sensors, so they know particulate concentrations, but they can actually see where the smoke is moving, and then we can actually verify where the smoke is moving with the HRRR smoke product and some of the other smoke modeling that exists out there to verify how skillful that product is doing. So there's a lot of smoke applications too. I didn't want to go into that too much in depth because I didn't want to take up too much time, but we're also examining that too.
Okay, one last question, Chris. You showed what looked like a geocolor or a natural color visible to show the fog in the valley.
Yeah.
Do you think that goes beyond like situational awareness? Is that considered more of a technical tool now, or is that why did you choose that image?
Well, I just showed that image not to indicate that's something that we use here for situational awareness, because of course with the geocolor image you can't tell if it's low stratus or if it's actually fog. So I just showed that as an example to show how extensive the fog can spread through the valley, because with that particular image that I showed, that actually was fog there, that geocolor image. So that was from like 3 or 4 years ago. That was from legacy data. So, we can use the geocolor images to be situationally aware, but again, that doesn't always indicate whether we're looking at stratus or we're looking at fog that's actually, clouds on the ground. So, yeah, we can use the RGB in conjunction with other stuff, but I don't think that's really the direction we should be going. We should be using some of these other products that I went over to identify where the fog is developing. That would be my opinion.
Okay, thanks.
Sure.
Okay, at this point, I'll turn it over to Brian to take on any general questions.
All right, we wanted to open it up to have some Q&A, open Q&A, so we'll open the floor. Does anybody have any general questions about GO 16 or GO 17? Come on now, I know there's a whole room full of Western Region Sioux out there. All right. Well,
So I'll go ahead and ask a question. We've heard some, I guess, maybe varying information. I don't know if you folks are in the loop on this. So when are we anticipating that the non-operational data will be available to us in AWIPS? Do you have any inside intel on that?
that's a good question. Yeah, there are bi-weekly user readiness meetings, and so that's being tracked.
Okay.
And it gets updated every couple of weeks, as I just said.
Okay.
So the latest, let's call it a forecast,
Yeah, right.
is that early July would be the activation of the GO 17 SCMI on the SDN.
Okay.
So that would be for the CONUS region.
Okay.
Yeah, this is Scott. The day I've heard is the 9th. July 4th is a Wednesday. I think that's going to kind of play havoc with getting things out that particular week. But we'll see.
Yeah, and then shortly after that, there's going to be a transition to the fixed grid. So it may look a little bit different shortly after it's implemented.
Okay.
And we'll have some information on that as we get closer to that date.
Okay, sounds good.
Brian, I thought GO 17 was always being transmitted in fixed grid. Did that change? There's a change with GO 16 coming up, going to fixed grid.
Yeah, the latest.
No, and this is something that I had missed. We're each going to have to register. Okay. For the conference. And, because Christy asked me yesterday, I don't know,
Yes, Scott. I'm not sure. It's just the way it looks on the chart that there's going to be a few days before the switchover.
Okay.
I'm sure that'll change. All right. Any other questions? Thanks for that one, Chris. Going once? Going twice? Okay. Have a good day.
Thanks, everyone.